Bismillah ar-Rahman ar-Rahim. So we'll talk today about the methodology to design the subnets for any large network. As we said before, in terms of factors that you need to take into consideration for subnetting, we need to take into consideration the number of hosts that exist in a geographical area. So we need to divide our building or our university or organization into geographical areas. So to be able to estimate the number of hosts in each of these geographical areas. Okay, so this is one factor that we need to take into consideration. But remember, don't only look at the current situation. You also need to overlook or expect the amount of growth that will happen in the near future. Okay, because the problem now is that once you design your subnets and you design the number of hosts within each subnet, it's not easy to just move one host address from here to here. Unfortunately, it doesn't work. The main problem with that is that the routers, they route packets based on the network part, not based on the full host address, right? So we cannot just move one address from this subnet to this subnet. It doesn't work. So we have to, from the beginning, we have to design and expect the amount of growth that will happen in each geographical area, and then come up with the best number of hosts per subnet. This is one factor that we need to take into consideration. And then we always calculate the number of hosts per subnet based on the worst case. So what is the largest location here? So this will be our limit when it comes to the number of hosts. Also, we need to take into consideration the same way the number of structured locations and the amount of growth that might happen in that dimension as well, which means that, well, currently we have, for example, 200 labs. But in the future, we're expecting to have many buildings, and therefore, we need to take into consideration the fact that these 200 labs will probably potentially become 400 labs or 500 labs and so on. Because based on that, you also need to say, okay, so I need that many number of subnets. In which case, what you do is that if you have the address and you have this network part, now it's your choice to take this boundary for the subnet, move it back and forth. So this is your decision now, whether to take into consideration the number of subnets and the growth in the subnet dimension, in which case you dictate or you try to design the number of bits that you need to borrow from the host part, or the number of hosts in each subnet, in which case how many bits you need to allocate in the host part, and the remaining will be for the subnet. Okay, so this boundary can move back and forth, and it's the decision of the network planner or the network designer to decide where to put this boundary. This is the exercise that we need to work on today. And probably next week we'll talk about, can we have only one boundary here, or our network can have multiple boundaries, in which case we do subnetting on a first level and then we have to do subnetting again on a second level, which means that for group of subnets, the number of bits in the subnet will be, for example, 3. But for this group of subnets, the number will be 5. Okay, so this is the variable length subnet mask, which we will talk about next week. So today what we need to do is that we need to go through 3 exercises that will allow us to calculate the subnet based on some requirements. So the requirements are either on the number of subnets or either on the number of hosts per subnet, which will allow you to calculate how many bits in any part of them. Because if you calculate the bits on the host part to be 5, for example, then the network part is fixed, so you know how many bits allocated for the subnet, and therefore you know how many subnets you need to have. Or if I know the number of subnets, then I know how many bits I need to borrow from the host part, in which case the remaining will be the number of bits allocated to the host, and therefore I can estimate the number of hosts per subnet. And I don't know why I get this over and over again, and I explained this many times, but you need to pay attention to the question. If the question mentions explicitly the word host or the word user, this means that this is the number of addresses not taking into consideration the broadcast and network address. Right? But if I tell you that I need the addresses for this subnet, and I did not specify whether this is a host or not, then this means that all the addresses, including the broadcast and the network address. Okay? So we talked about this before several times, and it's good to just make sure that you understand this concept clearly. I added one activity for today based on some feedback that I got from some of the students that we need to have an activity related to the question in the quiz. And I did not feel that the quiz question was difficult in any way, but maybe this is me. So I added another activity related specifically to the question based on the feedback. And also I have to note here that there are few typos in the material in one of the activities, okay, which I need to point out. And therefore, based on these things, I had to make some changes in the activity, and I posted the new slides on Blackboard just this morning, okay? So make sure you capture the latest activity from Blackboard if you didn't already download it, okay? So we'll go through the first exercise, and in the first exercise, we just need to estimate or calculate the subnet based on this requirement. So we need this number of hosts in the subnet. So how can we calculate the subnet mask based on this requirement? Okay. واضح So this is this one is the typical situation for the WAN connections, or if you have a connection between two routers and no LAN or no hosts are connected to it. In that case, you still need two addresses for the interfaces of the routers. And in that case, it's A/30. So in that case, it's 255.255.A252.
Don't you have 2 bits for the host? So 2 to the power 2?
Yeah?
So 4 bits? Or you make it 2 to the power 2 minus 2?
If we have 2 bits, we have 2 to the power 2 minus 2 addresses, host addresses, right? If we have 2 bits, type. That's what we need. We need 2 bits only. The 2 bits, we subtract them from the 32, we'll have 30 for the subnets, right?
So how did we get 2 plus 2? So how did we get the subnet mask of 255?
Because if we have 2 bits taken for the hosts, then we have 6 ones and then 2 zeros. This is 252, right? Because we said before, we need to memorize these numbers. We don't need to convert them back and forth. We just need to memorize that 128 is 1 and all zeros. 192 is 2 ones and all zeros. 224 is 3 ones and all zeros. I don't have to convert these numbers back and forth, because this will take time. Okay, so 1023, in that case, I need 1025 addresses in total, right?
Yes.
I cannot have 10 bits in that case, so I need 11 bits. So 11 bits will make it /21. So we subtract 11 bits from 32, we have /21. And /21 in that case will be 255.255. Remember that. Here, if these 2 bytes are 16 bits, right? And we subtract it from the 21, we'll end up with 5 bits ones. So 5 ones and all zeros is 248.0. Do not forget this, right?
Why didn't we take 2 to the power 10? Because 2 to the power 10 is 1024.
Yes, because we need 1023 plus 2. This is for the network address and broadcast address. Okay, so if we have only 10 bits, this will give us 1024. So unfortunately, we need one more. And you cannot take 10 and a half bits. And again, the reason for this is mainly because the router routes based on the network part only. Okay, so you have to allocate number of bits for network and number of bits for host. Okay. The 200 is similar to 250, right? So I will not write this because it's exactly the same. If we have 10 hosts, then we need 12. 3 bits will give us 8, so I have to have 4 bits. So I have to have 4 bits, so this is /28. So this is 255.255.240. Okay. If we have 511, again, that's another number on the boundary, and I put it like this on purpose just to make sure that the concept is clear in your mind. So 511, so I need 513. Okay, so if I have 9 bits, this will give me 512. So I need 10 bits. So this should be /22.
24.
No, 22. 32 minus 10.
So 18.
Okay, so 22. This means that 255.252.
محتاجين دكتور
Dot
10
zero.
bits.
محتاجين 10 بيتس.
طيب
لما نقسمهم من ال 32
يكون الأول 8 bits، الثاني 8 bits،
أيوة.
16 بيبقى عندنا
6 ones.
22.
6 ones. تمام كده؟ اوكي.
طيب دكتور عندي سؤال عام. ليش احنا بناخد 32 وننقص من 32؟ ليش يعني احنا معنا اكثر من 32؟
ما هو the number of bits allocated to the IP address is 32. That's the constraint that we have.
Okay.
These 32 have to be divided into network part, subnetwork part, and host part. Okay? So anything will be taken or subtracted from 32. If we're talking about IP version 6, we subtract anything from a 128. We have 128 bits for IP address version 6. Okay? So this is the activity that I was talking about that I added it this morning. And you're supposed to categorize these addresses, whether this is a network address, broadcast address, or host address. And you just need to tick. Okay? If this is categorized as network address, broadcast address, or host address. Similar to the question in the quiz, but the question in the quiz was just true-false. So even some people, if they shoot in the dark, then it's 50% correct. Okay? But here we want to make sure that we understand the concept. And we can actually categorize the address clearly. So we need, of course, this is the IP plus the subnet combined. Okay? This is not what you get in the destination address of the packet. The packet will give you this part only, without the subnet mask. The subnet mask is stored in the lookup table of the router. Okay? So this part is the address. And if we have this subnet mask, will this be categorized as network address, broadcast address, or host address?
How we know the network address? How we know the network address? How we know that it is the network address?
You tell me. I want you to think about that, and then tell me what is the method here? What is the procedure?
In the first example, the last 7 bits must be zeros.
برافو عليك. طيب ما اهو ماشي. If the last 7 bits are all zeros, then this is a
network.
Okay. طيب.
All ones broadcast.
What?
Last one is hosted.
Anything in between is hosted. Anything in between. If it's neither, then it's hosted. And here I didn't tell you whether this host address is the first host address, second host address. Doesn't matter. Anything in between which is not a network address and it's not a broadcast address, it's by default host address. Okay? So let's go through the solution. Ahmed. So the first one, 25 here, we just need to worry about this byte. So this byte 64 is actually 0, 1, and then all zeros. Right? But 25 ends here. Right? Because the other 3 bytes are 24. So 25 is 1 extra bit. So this bit belongs to the network part. The rest belongs to the host part. So the host part is neither all ones nor all zeros. Right? So in that case, it's host. Okay? The other one here, the 128 is 1 and then all zeros. So if we take 24 out, the 25th bit is this. So the remaining part will be all zeros, which means it's a network address. This one is 19, and 224 here is a 1, 1, 1, and then all zeros. 19, these 2 bytes are 16, and another 3 bits, 19, so the rest will be all zeros, so it's network.
Why isn't this host?
As we said, we just need to find the host part. The host part. Okay? This number will allow us to divide this address into 2 parts, the network part and the host part. Here, I just care about the host part. If that host part is all zeros, it's a network address, as we said. If it's all ones, it's a broadcast. If it's neither,
بس دكتور يعني هون يعني مثلا خلينا نقول اللي هي اول واحده 64 صح 01 بعدين دوت بعدين all zeros صح؟
لا مش دوت.
ما في دوت.
لا هو this is the full byte. This is the full byte. So it's 0, 1, and then 0, 0, 0, 0, 0, 0.
Okay, so this is a
Okay? So if we take this bit and the rest will be host, so the host is neither all ones nor all zeros. So it's host. Okay? The 255, of course, I don't have to, because 26 is in this byte, and 255 is all ones, which means that the host part will be all ones, which means it's a broadcast. Here it's 30, 254. Remember, 254 has 1, 1, 1, 1, and then 1, 1, 1, 0. And when I say /30, only the last 2 bits are host part, right? So these last 2 bits are again neither all zeros nor all ones, so it's host. This one is, of course, it's a network address because 252. Remember, 252 is a 0, 0, and then all ones, right? So if I extract those 2 bits only, because it's /30, this means that it's all zeros, so it's network part. And this one, of course, is a واضحة يعني. 255 is all ones, so this is the broadcast. Okay? طيب.
دكتور في ال 252 مش لازم الاوكتت كامل يكون زيرو عشان يكون نتورك؟
مش الاوكتت، لا.
اللي بعد البريفكس.
اللي بعد البريفكس. يس، اللي بعد البريفكس. So in this exercise, well, the best way is just to forget about these. I want you to go through the calculations from scratch. Okay? What's given here is that you have this address, okay? And I want to subnet this address, or this network, yani, so that in each subnet I'd have 30 users. 30 users, huh? Okay? So I need you to calculate the subnet, the new subnet mask, and of course the prefix, which is, it's corresponds to each other. And then the first full subnetwork range, and here I did not specify the host range. Huh? Here I'm saying the first full subnet range. I did not specify whether this is host, broadcast, so it includes everything. And then the second and the last. Huh? The last. Okay? So forget about this and just try to calculate it from scratch. Yeah. Okay, so if I have 30 users, clearly I need 5 bits, right? So if I need 5 bits in the last byte, so the first 3 bytes are fixed, 192.168.5. Now I just need to worry about the last byte only. So if I have 5 bits allocated for host, so I have 3 bits for the subnet. So the subnet itself can start from 0, 0, 0, and then 1, 0, 0, and then 0, 1, 0, all the way right 1, 1, 1. So these are all the subnets. So all I need is just to convert this into decimal, and my job is done. That's it. So the first one will sorry?
You have 8 subnets.
You have 8 subnets, yes. If you have 3 bits for subnet, you have 8 subnets. So this first one starts from 0 clearly. And here again, I did not specify a host range. Pay attention to the question. Here it's the full range. So it starts from 0. Okay? Not host range. Okay? So it starts from 0. And of course, if you have 0, 0, 1, and then all zeros, this is a 32. So obviously this will end at 31. If you convert this to decimal, this is a 64. So clearly this will end at 63. Now I don't have to do this for each one to calculate the last one. For the last one now, you have 2 ways. Either you say it's 1, 1, 1, and then all zeros, so this is the beginning. 1, 1, 1, and all zeros is clearly 2, 2, 4. And obviously this one will end at 255.
Yes.
Okay? Or you start from the 255, you say it's 1, 1, 1, and all ones, 255, and then subtract 32 addresses. So the beginning will be 224. It's whatever you see is easier for you. But in all cases, I don't need to calculate the 3rd range and 4th range and 5th range to be able to calculate the last range. Huh? If you do this, you'll waste time for no reason. Okay? Any questions?
Add every time 32.
Yes. I have 32 addresses, right? 32 host address, 30 host addresses, and 2 for each one for broadcast and network. Okay? To get the last address, you add 31, right? But to get the network address of the next subnet, then you add 32. Yes. Right? Any questions? So next time, inshallah, we'll talk about variable length subnet mask and try to motivate why we need variable length subnet mask, and then we'll go through some recursive subnetting, and then we'll get to the considerations for IPv 6. So probably next lecture we'll finish chapter 9.